okay? The ability to create complex geometric forms according to some kind of mathematical, physical criteria. Yeah, aerofoils. Yeah, you name it, and it's something that there are lightweight structures. Yeah, so there are optimal structures. Okay, what we call topology optimization. So those principles essentially are determined by our physical environment. So we can get to an optimized structure, something that has the optimal weight characteristics, load-bearing characteristics, geometrical characteristics. So they can be defined by aerodynamics, fluid dynamics, by static load, by dynamic load, whatever. Okay, so that is, and particularly why aerospace, because the amount of energy that's required to lift a vehicle or into the air, the lighter it is, the less fuel you use. Okay, so it's all about fuel economy. Okay, so that is why aerospace and similar industries use additive manufacturing. They use it for other reasons, but that's the primary goal. Second one, automotive. So automotive use it because they want to create complex products as quickly as possible to meet the market, to get the time to market, speed as fast as possible. So they use additive manufacturing because it's the fastest way to get their prototypes built and to be able to test them and validate them and get them ready for the market. Okay, so it's time to market. So they looking at additive manufacturing because we are, as consumers, very demanding. All right, and we choose based on what we think is the best possible product. So everybody that's in the consumer industry is using additive manufacturing to create their prototypes because it's the quickest way to get them to market. Sometimes even manufacturing them using 3D printing. Not always, but sometimes. Or sometimes they use 3D printing to manufacture as a way to get the first of their products off the line while they're preparing all the tooling to do mass manufacture. Okay, so it's not about the customization or complexity of form, it's about speed. Medical is about complexity of form, but from the perspective of customization. So they are basically saying, one of my favorite sayings is, you are unique, okay? Just like everybody else, okay? And the point behind that is that, if we're really talking about customization, or personalization, sometimes they're now calling it, there's a bit of a difference between the two, then we're talking about somehow scanning you in order to get your geometry so that we can then build parts which are suited most for you. Like a tailored suit, like a tailor measures all your sizes to make you the suit that fits you. Okay? It's in fact what we used to do centuries ago. Okay? This is what every manufacturer did, was customization, because they worked directly with the client to produce what the client wants. So that was customization and personalization. Okay? Exactly. You can't do that for millions of people. So, but now we can, because we've got additive manufacturing, we've got 3D printing. Mass customization, exactly. Mass customization is customization for mass production. Okay? So this is the world that we now live in, where this is becoming possible. Okay? Now, we're rapidly moving into another era, which is sustainability and circular economy. Because a lot of this is, yes, okay, it's great to have all of this functionality, but we're destroying our planet in the process. So now we then have to think about, well, how do we do this in a sustainable way? So again, all of you guys that are thinking about new areas for research, then definitely that's one area in particular. And you know, have to balance that against the complexities that of products that we're trying to create as well. So maybe things like, I mean, topology optimization is partly to do with that, lightweighting, fuel economy, but then what about the recycling of the materials? There's a lot of work currently on 3D printing with composites, and that's not a very sustainable technology to be working in. So you've got to think about, well, how do we deal with those composites in terms of recycling and recovering of materials, etc. So it's an interesting direction. The fourth one I mentioned was entrepreneurial, yes? Yeah? So you were just going to ask me that, yeah? Okay. The reason why I label this one, and this is actually a more recent addition. If anybody read my book, the first three are mentioned in the book, but the fourth one is not. This entrepreneurial activity is related to innovation and the ability to develop new ideas. Okay, so this one I think is quite an interesting development. The reason why I include it is because I think additive manufacturing, in conjunction with other technologies, it's a thing that I label as technology convergence or convergent theory. It's basically saying that certain technologies are now ready to be used on a mass scale, and I think additive is one of them. I mean, you said about 3D printers being $2,000. You can buy 3D printers for $200 now. You know, I mean, these things are becoming almost consumable items in themselves. You know, people can buy them. If you go into Europe and Australia, you can buy them in hardware shops. You know, they're on the, you know, they're on the shelves. You know, you just pick a box up like you would a lawnmower or a washing machine.
But what you want to do with the printer is make sense.
So this is the point that I'm leading to, is that basically it's a tool. And you know, if you're like me, I'm not very good at making things. Okay, so these guys at the back row. Okay, you're probably good thinkers, but not good at making things. Okay. All right. The issue is I buy lots of tools, and I don't use many of them. Okay, I prefer somebody that's got a little bit more skill than I have to make things. Okay, my wife asked me about putting shelves up. I usually find somebody else to put the shelves up so that they stay up. Okay. Huh? Yeah, exactly. So it's not what you know, it's who you know. Yeah. Okay. So the point I'm trying to make here is that yes, in the right hands, a 3D printer can be an extremely valuable tool, and they can make extremely useful solutions, either for themselves or in a commercial sense as businesses, whatever. Okay, so my point here is that 3D printing, I would label microcontroller technology like Arduino. I'd label CAD softwares that are now becoming almost, and what I characterize these as, they are accessible, i.e. they're easy to get hold of, they're very low cost, and they're easy to use. Okay, I mean, I remember, I did my first degree in electronics. So I remember programming in machine code with microprocessors, and I know how difficult that is. Nowadays, it's so much easier. And you've got all the various equipments that you can plug in to create a very versatile and specific solution to problems. So innovation, a lot of other things, drone technology, the internet itself, the fact that you can set up an internet business, related business, you can actually, e-commerce, all of these things are now so easy, and that they've all kind of converged into a tool set that you can use and you can configure and reconfigure to suit your own purposes. And I see 3D printing is part of that, because you've got the physical and the virtual. Okay, so that's why I will label about entrepreneurial activity. So basically, it's part of a range of technologies that now it makes it so easy for you to set up your own business facility. And it can either be for the 3D printing business itself or using 3D printers for another business. So there's so much versatility in all of this. Okay? So,
in this entrepreneurship, we get very low cost of budget investment to make the products into the directly run into the market.
Yeah.
It's possible only by
Yeah.
the 3D printing.
It's exactly right. When I started looking, I've helped students set up businesses and other entrepreneurs set up businesses, and they come up with a new design of a new design of a bottle, water bottle, and they want to test it on the market. They want to be able to validate this. And they can't really, in the old days, you would have had to develop a tool which would have cost you at least a few tens of thousands of dollars. And you would have a tool that would then only be capable of creating, hundreds of thousands or millions of parts. But what if the original design was no good? So you did prototyping. That's why we used to call it rapid prototyping in the early days, because you would use a 3D printer to test out, or even maybe develop a short-run tool or something like that to get your part, to make enough of these to be able to test the market without investing lots of money, which is what you're saying, basically. Absolutely. Okay, I think we're done now. Ravi? Yes? We're good?
Yeah.
Time? Okay, good. All right. Break for lunch. Okay, thank you. Okay.